In our last video, we learned how to convert from degrees to our new unit of radians, something we hadn't seen before this section of videos. Today, we're going to do the opposite part of it. So we're going to go starting in radians and turn it back into degrees. And this is usually, like when you convert starting radians, you will typically see a pi in your answer. They might have multiplied out into decimal, but leaving a pi in there is generally the way to go if it's going to be a somewhat nice fraction. Let's say I had 5 pi over 3 radians, and I wanted to convert that to degrees. If you recall, 180 degrees is the same thing as pi radians. That's kind of my conversion factor that I'm going with here. On this problem, my units are already in pi, or in radians. There's already a pi in my answer. You can think about it. Here are my radians up top. I want to put my radians in the bottom so they'll cancel. Or if it's easier to think about it, you're basically with the pi, your pi's want to cancel out. So you're going to try to make it so your pi goes in the bottom on this one, and your 180 goes up top. So your pi's will cancel. You're going to multiply this out and simplify. And if you do that, 5 times 180 and divide by 3, you're going to get, oh, this is degrees right here, by the way. I'm going to put that symbol because that's the unit that's going to be left over. If you do that, you get 300 degrees. So 5 pi over 3 is the same thing as 300 degrees. And I'm going to do just one more example of this type. Let's say I started with negative 3 pi over 4 radians. Again, we multiply by our conversion factor, 180 over pi. And when you cancel your pi's and you simplify your problem, you're going to end up with negative 135 degrees for our problem. Negative 135 degrees, same thing as negative 3 pi over 4. I'm going to go ahead and write down that summarized. So, to convert from radians to degrees, you're going to multiply by 180 over pi, 180 degrees over pi. So you basically just invert or do the reciprocal of what we did in our last video. To wrap up our discussion, I want to talk about 2 examples similar to what we saw in our old angle measuring videos. So what I mean by that, let's say we had a picture like this. We had a little angle down here. And we know that this piece right there is pi over 6 radians. They could ask us to find the measure of the yellow and let's go with green, the green angles. So a similar approach, find the measure of each of those angles. I won't actually write that up there, but that's the idea. Well, if we look at this right here, we got to think about those key angles to know. I know, I'm going to go for the yellow first, by the way, that if I go all the way from here to here, I'm up to pi radians. And let's see what else I know. I know that if I go from here to here, that whole quadrant, that's going to be pi over 2. Now, I want to make a common denominator here because I think it'll be easier to see what's going on. If that's pi over 2 from here to here, pi over 2 is the same thing as 3 pi over 6. So this whole quadrant from there to there is 3 pi over 6. If I used a pi over 6 of that, I'm going to have 2 pi over 6 left over. So I'm going to erase my extra stuff right here. This guy right here is 2 pi over 6, which is the same thing as pi over 3. So it really is a matter of just doing common denominator stuff to get your answer, like you have to be able to do with fractions. So I'm going to do my pi for my 180 plus 2 pi over 6. If I get my common denominator here, multiply the top and bottom by 6 on this guy, I end up with 8 pi over 6, which is the same thing as 4 pi over 3. So my yellow angle is 4 pi over 3. To get my green angle right here, I know that this whole quadrant is pi over 2. So I'm really doing a pi over 2 plus a pi over 6. And I realize my answer is going to be negative when I do this because I'm going clockwise on this one. So in order to get my common denominator here, I'm going to multiply top and bottom by 3. And I'm going to end up with 4 pi over 6. I'll make that negative because I'm going clockwise. So it's negative 2 pi over 3 for the green angle in radians. And I'm going to do one final problem in this video. Another picture here. Let's say I had an angle over there, and I know that this part, ooh, that doesn't make sense. Let me change what I had in my paper here. My answer didn't make sense. Say this guy right here was pi over 4, if that was the case. Now, my picture looks a little off on this one, but let's go with it. You know what? I'm actually going to make this a pi over 5. Get kind of a weird fraction going on here. And let's say I want to figure out what this angle was right here, as well as what this angle was going, let's see, right there. So I want to take a look at my picture right here and see what's going on with this. Now I know this whole first quadrant is going to be a pi over 2. So if I want to find the black angle, all you would need to do for that is add those two guys together. I have the pi over 2 from this whole part, plus another pi over 5. So if I add those together, pi over 2 plus pi over 5, I'm going to end up with, let's see, a new common denominator of 10. That's going to be 5 pi over 10 plus 2 pi over 10. That black angle is going to be 7 pi over 10. And if I do it going the other way as well, my green angle, I have a full pi from this whole bottom part. And if that's a pi over 5, got to deal with the rest of the fraction there. Let's see. This whole quadrant is a pi over 2, which, let's see, pi over 5 is the same thing as 2 pi over 10. And this whole thing is going to be a 5 pi over 10 then. So this guy right here, I'm kind of going through the math kind of fast at this point, is 3 pi over 10. So really what I have to do is pi plus 3 pi over 10. And if I get my common denominator in doing this, that angle is going to be negative, because I'm going in the clockwise direction, negative 13 pi over 10. And that's how you can try to kind of take the same process and apply it to problems.